Alright, moving on with organic nomenclature. This is lesson number 5. We're going to talk about ketones and carboxylic acids. So, first thing, ketones. If you've heard of the ketogenic diet, that's a big popular thing these days. It's getting your body to produce and consume ketones. But anyways, let's talk about what a ketone is. I'm going to draw this out real quick. A ketone is an oxygen that's double bonded to the carbon within a carbon chain. So this R and this R are the rest of the molecule. Okay, so that's our general formula. The suffix that we're going to use is unknown. So let me give you a quick example. Let's say we had this guy. Now notice that whichever carbon has the double bonded oxygen on it doesn't have any hydrogens because carbon's only going to bond 4 times. So that'll help you draw the structure correctly. So if we're going to name this guy, I'm going to see that there's 1, 2, 3 carbons. Our root for 3 is prop, and then we're going to add in that suffix prop unknown. Okay. If we were to write this condensed, you could write it as CH3COCH3, but we're going to learn later on that that isn't as clear as it could be. You're going to see that you could also draw it like this. So just FYI, either one of those are valid condensed structures. Okay, so I didn't put a number here in propanone because there's only one place that that double bonded carbon could be, where it's in the middle of the chain. So what happens if it's not? Well, let's try this one. Okay, so let's say we have this, and I'm going to do, okay, do as I say, not as I do. I'm not going to draw in the 500 hydrogens. Okay, so all of those, yeah, there's hydrogens, ta-da! Okay, so I count my carbons, 1, 2, 3, 4, 5, 6, 7. Our root for 7 is hept, and it's going to have that unknown ending on it, but we're going to put a number, and we're going to give it the lowest possible number, so it could be 1, 2, 3, 4, 5, or 1, 2, 3. So this is hept 3 unknown, or 3 hept unknown, depending on which one you like. So those are ketones. Let's deal with carboxylic acids. Okay. The general formula looks like this, where R is the rest of the molecule. And this is called, or the suffix is anoic acid. So we're going to shorthand it to COOH. Okay. You might have seen this somewhere. We're going to come back to that. Let's try this example. So you see that carboxylic acid is always going to be terminal. It's always going to be on the end, because carbon's only going to bond 4 times. Well, we've got 1, 2, 3 of the 4 bonds, so it's got to be on the end. Okay, so if I'm going to name this, I'm going to count my carbons, 1, 2. I'm going to think of my root S for 2, and then I'm going to add anoic acid. So if I were to write this condensed, I would have CH3COOH, which maybe in Chem 1 you saw written as something a little bit different. We put this is our acidic hydrogen, more on that later. And you called that acetic acid. And we learned acetate could be either this or this, or sorry, this first part. Okay, well that's why, because of this structure. So just FYI, ethanoic acid is acetic acid. It's what's in vinegar. But from here on out, we are no longer calling it acetic acid, we are calling it ethanoic acid. And one more for good measure. Again, I'm not going to draw in all my hydrogens. Okay, so 1, 2, 3, 4. 4 is bute. So butanoic acid. This has a very distinctive smell. So ethanoic acid is what is in vinegar. Butanoic acid is what is in vomit. And there's your chemistry lesson for the day. Enjoy, guys!